In Programming 1, we, at the end of the course, started talking about classes and objects, and we're going to continue that discussion here for the first few weeks in Programming 2. So here's a little bit of review, and in this first part we're going to talk about inheritance and composition. So I've made two classes. The first class is a class called Vessel. So Vessel is something that stores stuff, and there's an init method for the vessel. And the vessel has a volume and a material that it's made out of, and so we just store those inside the class as self.volume and self.material. And then there's a string method which just prints out the volume and the material that the vessel is made out of. Now we have a bool class, which is a type of vessel, so it inherits the class vessel. And notice that I'm also using different kinds of ways of documenting code. And in the bool class, there's also an init method and a string method. So for a bool, you have a volume, a material, a bowl type, which can be a mixing bowl, a salad bowl, different kinds of bowls, whether or not it has a lid and whether or not it's microwavable. So these two things are true or false, not true and false. So when we init a bowl, remember that we inherited the vessel class, and a vessel has volume and material. So when we init a bowl, we actually call the init class for the superclass. So bowl is a subclass of vessel, and vessel is a superclass for bowl. So we call the init method for the superclass, and we have to pass to it. You have to pass self, and then we pass in the volume and the material, and then that comes up here and constructs this and makes self.volume equal to volume, self.material equal to material. And then we also need to save the bowl type, the lid, and microwavable. So this init here could do more stuff, but it does some basics. But the idea here is pretty simple, that if you inherit a superclass, then you can use that superclass's init method. Okay, now I've also defined a string method for the bool class, and here's a different kind of if statement. So the way this reads is, do this if this is true, otherwise this. So if self.lid is true, then I want this variable lid to equal yes, and if self.lid is false, I want lid to equal no. And similarly, I want microwave to equal yes if self.microwavable is true, and if self.microwavable is false, I want microwave to equal no. The syntax on this is pretty important and a little bit strange. This is lid equals yes, and this is just a no. So the way this is executed, it knows that no will go to lid if this is false. It's, like I said, it's kind of different, but it's a short way to write this kind of if statement. Instead of writing if this, then do this, else write this, which would take like 4 lines of code. This is a quicker way to do this, and this is a pretty simple thing to do. So if you like this, then you can use it. If you don't, then don't. Okay, so the string method should return a string, and I'm going to make use of the superclass's string method by calling that, which will return a string for me that has the volume and the material in it. So we call them vessel with self, and then I'm also going to type out the bowl type and whether or not it has a lid and whether or not it's microwavable. Okay, so I have now constructed a bowl that has a volume of 2 quarts. It's made out of plastic. It's a storage bowl, and it has a lid, and it's microwavable. And now I can print this thing out using the string class. And let's see, we'll run this. And what do we get? So we output here, this print calls a string method, which then calls the superclass's string method, which outputs the volume and the material. That's up here, volume, material. And then the bowl type, lid or not, and microwavable or not. And I've got more code out here. Oh, there is a slider down. There's a slider bar down here, you can see. So There is another way to actually get at the superclass's information. You can actually call super. In this case, you need parentheses on here, but you don't need the self, and that will do the same exact thing. So the idea here is that if you inherit a class inside of another class, then this subclass can reference the init method, the string method, and other methods from the superclass. Now, generally speaking, in Python and other programming languages, inheritance is actually is frowned upon. So we often use something called composition. This is the same program. It does the same thing, but it's written differently. So this will look familiar. Class Vessel is actually the exact same thing that I had in this inheritance program. So nothing's changed there. Well, except for this isn't a superclass. Should change my comment. Okay, so it has an init method, and it saves volume of material, and then it has a string method which returns a little string printing out the volume of material. And bool is not a subclass of vessel in this case, so I probably should have rewritten that too. Anyways, in the init method, we do things a little bit differently. We're still passing in volume, material, bool type, lid, microwavable, but in this case, we do a composition where this variable, self.vessel, is of type class vessel, which we then init with the volume material passed to us here. And then we have the bool type and the lid and the microwavable. This code is the same. If self.lid is true, we're going to have lid be, we're going to print out a yes basically. And if self.microwavable is true, we'll print out a yes. The return here is different. So remember that in this case, this isn't vessel is not inherited. It's actually one of our variables. So self.vessel is of type vessel class, but because it's a vessel class or vessel object, we can get a string for that and print that string out. So we're going to make a string out of self.vessel, and then we'll print out the bool type. We'll say is it a lid or not, and we'll have lid here, which remember is this variable, which is yes or no, and microwavable. And if we run this program, it does, oh, it's not my list. It does the exact same thing. The problem with inheritance is it can get very complicated. If you only inherit one superclass, then it's not a big deal. You know, to use the init, it's not the prettiest thing in the world. This is not really pretty looking code. But if you had to inherit two superclasses, or this class inherited another class, then this use of the init can get pretty nasty looking. It's doable, but not brilliant. Composition, on the other hand, works beautifully. So generally speaking, if you have a choice, use composition. There is one exception to this, he says. With a pun. So it is acceptable to inherit an exception class to build your own exception class. So I've made an exception called bad user. I think anybody who's ever done any programming has had to deal with users would love to have a class named bad user. When it inherits the basic exception class, in the past I think I've actually used value error in here, but this is the more general version of creating an exception class. And then I have a class name which does something kind of silly. So it asks the user to type in a name. The name has to have at least 3 letters, and the third letter has to be an integer. Oh, I missed the integer bit there. So it asks 3 letters and integer. And then it checks to see if they actually typed in the third letter as an integer and it has at least 3 letters. An easy way to check to see if it has 3 letters, well, you could just do an if statement. But since we have to check 2 different things, I am plugging in the index for the third letter. If that index doesn't exist, it's going to cause an index error. And then I'm converting that character to an integer. And if it's not an integer, then we'll get a value error. And in either case, I raise my bad user exception. So instead of getting two different kinds of errors from this, I'm going to get one error, bad user. And then down here, we're going to try to print a name. So this right here, this name with parentheses, will instantiate class name. And if the instantiation doesn't work, in other words, if this fails, then we're going to get a follow the directions error message. So what happens if we run this? If I just type in a letter L, then I get something that says follow the directions. So in that case, we've got an index error because the string that I typed in for self.name only had one character in it, so this index 2 doesn't exist. So we can run it again, and I'll type in 3 letters this time. So now that index 2 will exist. We won't get an index error, but when we try to convert that to an integer, we run into a problem, and we get a value error, which raises the bad user exception. And we can do AS2, and that just then prints back what we typed in. So in this case, no errors were erased, and then so this was instantiated. Self.name become AS2. Then we printed it, so in the print command it goes to the string method, and we just get self.name, which was AS2. You can have more than 3 letters if you want, that's okay. Alright, so the general idea here again is that you can inherit if you want. It's not the best programming style, it's not recommended, so we do recommend that you use composition if you can, but there are exceptions to the exception, and one of those is, I don't think I said that right. One exception is when you're making your own exception classes.